Groups. The vertical column in the periodic table is known as group. In terms of electronic structure of the atom, a group consists a series of elements whose atoms have same outermost electronic configuration, but they have different number of total electrons. There are 18 groups in long form of periodic table according to the new recommendations of International Union of Pure and Applied Chemistry IUPAC. The groups are numbered from 1 to 8. Previously, these were numbered only from 1 to 8 as A and B groups. Both the systems of numbering the groups are given in periodic table. However, the old convention is still used in many books. The first two groups on the extreme left and last six groups of on the extreme right involve the filling of s and p orbitals respectively. These groups represent the main groups of the periodic table and are numbered as 1, 2, 13, 15, 14, 16, 17, and 18 corresponding to general configuration of NS1, NS2, NS2, or NS, NP3, NS2, NP2, NS2, NP3, NS2, NP4, NS2, NP5, NS2, NP6 respectively. In the old system, they were denoted as 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, or 0, respectively, corresponding to general configuration of NS1, NS2, NS2, NP1, NS2, NP6. The elements present in these groups are known as normal or respective elements. The first three periods containing 2 and 8 electrons involving the filling of only s and p orbitals, but the fourth period involves the filling of 3d orbitals also, and it results into 10 more groups. These grand groups lie in between the first two and last six groups, that is between group 2 and 13, because 3d orbitals are filled after 4s but before 4p orbitals. These were labeled as b groups, that is I1b, 2b, 3b, etc. The elements present in these groups are called transition elements. The name derived from the fact that they represent transition or change in character from reactive metals. Elements of group 1 and 2 on the side of non-metals. Elements from group 13 to 18 are on other side. The IUPAC names of the elements with atomic number more than 100 years are given below. For example, atomic number 101, Unilium, symbol UNU, IUPAC official name is Mendelevium, IUPAC symbol is MD. Now, classification of elements into SPD and F blocks. The long form of a periodic table can conveniently divided into four main blocks. In this division of elements, which involve the filling of particular orbital, SPD or F are grouped together as shown in figure 1. Number 1. S block elements. The elements in which the last electron enters the s orbital of their outermost energy level are called s block elements. It consists of elements of groups 1 and 2 having the ground state electronic configuration of outermost shell as ns1 and ns2 respectively, where n stands for outermost energy cell. The elements corresponding to ns1 configuration are called alkali metals, which those corresponding to ns2 configuration are called alkaline earth metals. Thus, the general configuration of S block elements may be expressed as general electronic configuration of S and S block elements NS1 to 2. P block elements. The elements in which the last electron enters to the p orbital in their outermost energy level are called p block elements. The elements of group 3A or 13 to 3A or 15 involving addition of 1 ns2 np or 2 ns2 np, 3 ns2 np, 4 ns2 np4 gives, and 6 ns2 and p5 respectively in p orbitals and s orbitals are filled in their atoms constitutively p block. The general electronic configuration of the atom of the block may be written as ns2 and p1 to 6 d block elements, the elements in which the last electron entered to the d orbital of their last but one called primitive energy level constitute d block elements. These blocks consist of elements lying between s and p block starting from fourth period and onwards. They constitute group 3b to 3 to 8b and 1b to 2b or 3 to 12 in periodic table. In these elements, the outermost shell contains one or two electrons in their s orbital, but last electrons enters the last but one d subshell, that is 1 to n is equal n minus n, that is n to 1 d. The general electronic configuration for the atoms of d block may be written as n to 1 d 1 to 10 n s 1 or 2. General electronic configuration. F block elements. The elements in which last electron enters the f orbital of their atoms are called f block elements. In these elements, the last electron is added to find two-third to the outermost energy level. This consists of two series of elements placed at the bottom of periodic table. The first series allows lanthanum La, and the elements present in the series are called lanthanides. They are also called rare earth metals. The second series follow actinium and the elements present are called actinides. They are one of radioactive nature. These the general electronic configuration of F block elements may written as N to 2 F 1 to 14 N to 1 D 0 to 1 NS2. Cause of periodicity. The reoccurrence of similar properties of the elements after certain regular intervals when they are arranged in the order of increasing atomic numbers is called periodicity. The classification of elements in the certain families were based upon the observed similarities in physical and chemical properties, but why do they certain elements exhibit similar properties, and why do similar properties occur at regular intervals of atomic numbers were some important questions to be answered. We know that an atom consists nucleus surrounded by electrons in ordinary chemical reactions. The nuclei and the atom do not undergo any change, and therefore it is distributed of electrons in future. In further, it has also found that properties of atoms do not depend much on arrangement of electrons in their inner shells. Thus, it primarily it primarily be arrangement of electrons to the outermost shell, called the valence shell, that determines the property of atoms. For example, the electronic configuration at the atoms of alkali metal group shows that they all have one electron in 3s in s orbital of the outermost valence shell. Proceed by a noble gas configuration ns2 and p6, but for li ns2. The general electronic configuration of these may be written as noble gas ns1. Periodic properties. There are many physical and chemical properties of elements which show periodic variation with atomic number. Some of these properties, such as valency, atomic size, ionization enthalpy, and electron in affinity and directly related to the electronic configuration of the atom, while some properties such as melting point density are indirectly related to electronic configuration. Atomic radii. This is very important property because many physical and chemical properties are related to chemical radii. Generally, the term atomic radius means the distance from the center of the nucleus to the outermost shell of electrons. However, the absolute size of an atom is difficult to be defined because of the following reasons. Number one, according to the probability pictures of electron, an atom does not have well defined boundary. The probability of finding the electron is never zero, even at large distances from the nucleus. It is not possible to isolate an atom and measure its radius. The probability distribution of an atom is also affected by the presence of other atoms in its neighborhood. Therefore, the size of atom may change in going from set environment to other. The intermolecular distance between the nearest neighboring atoms is called metallic crystal, determined by X-ray differentiation. Di- Diffraction. This is divided by 2 to calculate metallic radius.